Okay, good afternoon, everybody. Our report today is about beam search. At first, it will like recap what is our task. Our task is image captioning. We are going to give our model an image, and the task of the model is to give us a description, a sentence, describe what is the object, what are the objects in the image, what there are like attributes and action. Let me also give you a brief recap about the model. We did our data set is called Flickr 8000. It's have like 8000 images. We using ResNet 34, using the fourth layer, we get all the feature vector for our images, and we save them to the disk. So during the training process, we just go through the decoding process. So we save our time. We used like a very simple attention mechanism with our decoder, which is an LSTM. It's a very basic model, and but here we are like we are caring about the different ways of decoding, like to generate the sentence, and this like this decoding ways doesn't involved in the training process. It's just when we are going to inference our model. Of course, we have the basic one, the basic decoding method, which is the greedy method. It's a famous method. Just every time, at every step, get the word with the highest probability. It's very basic, very easy to implement. What like its negative or problem, it's that we all know it's the problem of the greedy algorithm, which is it's not necessarily like that the word with the highest probability right now give us the best sentence overall at the end. This is why we need something like beam search decoding. The idea of beam search is like this. Can you see the image?
Yes.
Okay, so the main idea of the beam search is that we are going to do some generation each step, and each time at each step we will keep the for example here in the image the highest 5 words. So here, for example, we started from the word start. We have 5 words. For each one of these 5 words, we will also generate 5. So at the second step, we will have 25 words, but we keep just the highest 5 of them. Another time, from these 5, we will generate 25 words. We will keep the highest 5 words, and etc. etc. We'll continue in this process until we reach the end of the sequence length that we already predefined to our model. For example, in my model, the predefined length of the sequence is 36. So we'll do this procedure 36 times. At the end, we have 5 possible words. Here we can get the highest one, the highest probability, and also beam search could give us the possibility to generate more than one caption to each sentence. And this is good because sometimes you can describe one image in 2 different ways. Or you can, for example, add a description or describe like one object and ignoring another. So unlike the greedy search algorithm, beam search can give us multiple answers, which is like more advantage to this algorithm. The implementation, it's like pretty like basic and easy. We define the beam width as 5, as in the image. Here we need to process each sentence or each sample from our data set alone. We can't do like we can process it as a batch. And this is one of the negatives for the beam search. The greedy is, of course, much faster than beam search. So we go through our batch, one sample by time. We start giving the start word. We get the start word and we build the starting node. Here, let's define our node. Each node in the beam search, like each one of these nodes, what it has the hidden state of the LSTM model, the previous node, so we can track back at the end, the word ID, so we can like go from the index to the word, the logarithm probability, which is the probability that this word is like it's how it's word, like what is the probability that this word it's like now it's placed in this sentence right now, and the length of the sentence till this word. We calculate the method evaluation. We calculate this, which is the average of the probability to the length of the sentence. Back to the beam search decoding algorithm. We build the starting node. We build our queue, and we start by doing the first step, which is from our start node, give us the next 5 nodes, which is by this function. Step for one node. This function take one node, run our model in this node, and returns beam width best next word. So this function will run our node from our vocabulary. For example, if we have 10,000 word vocabulary, he will give us back like the best 5. We'll save them in the next node, and then we will go for this while. What we do, as I said before, each time we get the beam width node for each one of them, we generate all the next node, then we get the highest one. After that, we also, of course, we save our results to the end nodes whenever we reach the end of the sentence. Here, from the end node, we get like here I just get the best sentence. We get it and we track it back. Let me show you an example. It's some like differences between the greedy search and the beam search. For example, for this image, a dog is running through a yard. A brown and white dog is running in the grass. So you can see that the beam search, for example, here, give us like more description of an object in the image. Here, for example, a girl in a pink shirt and a blue shirt runs through the grass. A group of young children running in a grassy field. Here I think the greedy like generate more like we can say more accurate sentence, or more like representing sentence to the image. I calculated the blue score for the greedy and for the beam search. For the blue one, I think always the greedy search will wins. but for the others, the beam search like have like higher results. For me, I thought that I would reach like more better results in the beam search, but I searched on the internet and I faced like others also. They said like the beam search it like gives better sentences in a way in the way that the sentence is structured, but somehow like the greedy can keep the results can have the better results. Also, I want to add something. There is this repository on GitHub, which I mainly take the idea of the code from here. But the main differences between my implementation and his implementation is that he made somehow a modification to the algorithm. His modification is that he each time took the best node. Not like in my implementation, each time I get the 5 highest node or 5 highest word at this step. His implementation, he get the highest word and implement the algorithm for 2000 time, because in his implementation sometimes like it can't end. And in my implementation, I just run for the 36 time, which is the maximum length of my caption. In his implementation, no. He every time get the highest word till he reach 2000. Why I am mentioning this implementation? Because this implementation, it's faster in the inference time, and its results like are very near like my implementation, which is the standard of the algorithm. And that's it for the beam search. If there is any question.
Спасибо за доклад, Хабиб. Если есть у кого-то какие-то вопросы, можете задать на русском, на английском языке. Хабиб ответит.
Hi. Can you remind me of disadvantages of beam search except speed?
The disadvantage of beam search, first, there is the speed. Of course, greedy search is like have more, it's faster than beam search. The second, we can say the complexity of the algorithm. Of course, you are writing more complicated algorithm. It's easy to implement, but like it's comparing to the greedy, which is I think the standard. Beam search is more complicated to implement. Also, the memory. It had like you need more memory because you are building the graph, and this is a problem, because when you want to generate, like for example, for each image 5 caption, you can put the beam width not to 5. I put it 5 just to get the results fast, but you can put it like for example 10. This will make the algorithm run like take twice the time, and I think more than twice the size on your run. This is the disadvantage of the beam search. Also a disadvantage, which is like I can't prove it, but this is after like running several examples and experiments, I found that the beam search, in general, it gives you a good sentence. You can feel that the sentence that given you by beam search is like more like a good sentence. Like for example, here a dog is running through a yard. A brown and white dog is running in the grass. So you feel that this sentence is more informative, more describing of the image. But this sentence, it can't like when you are comparing with the greedy in the known metrics like cider and blue, because the greedy search, of course, it gives you the best word every time. So at first I thought that the beam search will win the greedy, but I saw on the internet and in my experiment, I saw that no, the greedy search always win, or in my case, always win, especially in the blue one score, because the blue one score it just gives you the precision of one word. The anagram of you, the anagram when you are splitting the sentence, you are splitting the sentence into one word. And because greedy gives you the highest probability each time, so this word is probably more probable to be accurate. This is why like the greedy wins in the metrics perspectives.
I heard that beamsearch sometimes gives worse result than greedy search. Is right? And in which cases?
It depends on your definition of bad results. How are you comparing the like your caption with your references? If you are like you are comparing using a metric like the blue or cider, yeah, it could gives you not a bad result, a worse result than greedy, but of course not a bad result, because your model is trained and your model can give you each time a probably like a good word, like a good word to produce at this step of the sentence generation. But it could give you, yes, it could give you worse if, for example, like for example here the word and. If the word and in this sentence gives the sentence high probability, because the word and it's very famous in the English language, so it gives this sentence more probability, and this probability that and gives it cover the low probability that the word brown gives to the sentence. If you imagine how the sentence is generated, first you get the word brown, which has a low probability. Then the word and came after that to increase the probability of the sentence. So this is why sometimes you have not bad sentences, worse sentences in the beam search, because there is some words in the sentence that gives your result a good probability and covering the low probability of other words. Yeah, did you get me?
Yeah.
Okay. Any other question?
Just to clarify, do we have gradient here when we're using beam search, or just
No, not at all. The beam search, it comes just in the inferencing. It doesn't take any participation in the training, so it doesn't have any participation in the back propagation of the training of the model. It just when we are inferencing our model, we just keep tracking not just the best answer. We keep tracking multiple alternatives. If one of these alternatives give us a good result, we will take it.
Okay. Thank you.
Thank you.
Well, I think we can try to to implement that in image captioning. So if Dmitry have a look at that, and I think we can combine results and find best way to implement that.
Yeah, sure.
Так, ну, вопросы, как понимаю, исчерпаны. Если ни у кого не возникли вопросы, предлагаю перейти дальше к следующему докладу. Так, все, Хабиб, спасибо большое за доклад. Так,
Мгм.